So this time I'd like to see if we can actually bind a class using runtime type information using this RTTR library. Yeah, let's bind a class like we did before, where we had a Sprite class and we bound that to Lua, and we did all like a manual binding. I'd like to try and start doing the same thing again, but this time we'll make it so that we can bind any class that we register. So that's the idea, and just to start with, we're going to get it so you can just make one of these in Lua, and that's all you can do at the moment. We won't go any further than that this time. In a long time ago, in a few videos back, we had this Sprite class that we were using this as our example to bind to Lua. So I'm just going to copy that and put it into our test registrations. So just exactly the same class we had before. So this was the one we successfully bound to Lua, and we accessed this draw move, constructor, destructor, and we managed to access these public variables. So what we want to do is register this type with RTTR, and hopefully see if we can we can make one of these in Lua, and just make one for now. Yeah, nothing more. So the registration, according to the docs, we do class. Class is called Sprite, and we give it a name, so I'm going to call it Sprite. That's the name that we'll use in Lua as well once it's registered there. And then it has like this kind of like dot syntax where you say dot and then you register all the other things you want. So I'm going to say register the constructor, and I'll tell you what, we might as well register the other stuff here as well. There's method move, which you say Sprite move like that, and we've got another method draw, same thing. Oh, I put Dave, that's my name. Draw, and to register we've got the X and Y property, so you'd say property X, and you do Sprite X, and same thing for Y. So that's just a really basic registration. That should just take our Sprite and it registers the runtime type information for it. So we should be able to use that if that builds. So you may be using your own runtime type information, or you may not be using this RTTR, but the principle is the same, that you somehow got to register this, and you see we're giving names to these properties of this class. And ideally, the place we want to get to is in our binding. We want to be able to do this. For now, all we want to do is we're going to call Sprite new, and it will make a Sprite. So that's the goal that we've got to get to. So obviously to do that, we've only handled global methods so far in our binding, which is down here. So this is the bit where we're handling binding global methods. And we need something that can just bind classes now as well. So we've got a bunch. Let's just, again, we'll do kind of what we did with the global methods. We'll go through all the classes and we'll just bind them. So we should be able to, I think, loop through all the classes. Class to register, which are stored in type. Get types, is it? Get types. So that's just going to go through all the types, and I'll just start by printing the name of the type so we can see what's there. We say to string, is it? How do we do that? Get name. Get name. There we go. Get name to string. Let's just start by printing out so we can see what we get. So this should give us a list of the things that we're going to register when we run this method. So let's just see if that runs. So we've got void, int, short sprite, pointer to sprite, and for some reason it's also registered the shared pointer to sprite. So we're actually not interested in most of those. We're only actually interested in Sprite at the moment. We're not interested in these other ones. So maybe we can narrow that down. I think we can say we can say is array is class. So we're only interested in the classes. Let's try that. So that just gives a sprite and this shared pointer that's been automatically bound. So we'll just leave that like that for now. But I'm not sure we're like, for instance, I'm not using shared pointers, so I'm not interested in binding them. But it looks like they're going to be bound anyway with this system. I mean, we could narrow that down some way, but we'll just leave it as it is for now. And obviously our sprite.new has failed because we haven't created that yet. So what do we want to do? Well, we want to do what we did before, really, which is if we can find it down here. It's going to be very similar, except we're not just binding a specific thing now. We're actually going to generically bind so that we can use it with any type. So what we did was we made a table. There's our table. We set a global called Sprite. So we made a table called Sprite, and then we created a new field on that table, and we pushed in the function. Was it? Oh, we've actually done some extra things with the Sprite Manager here, but we pushed on this function called create Sprite, and that got called every time we did a sprite. So we're going to do the same thing, except it's not going to be create sprite. We're just going to create any type now. So let's go through and do that again. So we need a new table to store our functions in. So there we go, and we need to set that as a global. So I'm going to push that on. I'm going to push that on again. So I'm just going to push value, which just takes the. It's going to take the thing that's at -1 on the stack, which is table, and just push it on again. Because I'm going to do set global which takes the last thing on the stack, which is our table, and we need that. This will be the name that we give to this table as a global. So last time we called it Sprite, but this time actually it's actually this, because now we're binding any type. So the name of it is just the name of our class, which is Sprite. So that's bound our global like the same way we did before. I'll just push the value on again, because currently we've got the table left on the stack, and then I'll push it on again, because now we need to push on the function that we want to call whenever new happens. So before we did like push, I think we did push C function. I'll just do push C closure instead, because that's the same thing, except it takes the number of up values. It wants the function to call, so I'll just call this create user datum, because that's what it's going to do. It's going to create a user datum for any type that we throw at it, and currently it takes no up values. And then we need to set that new method, don't we? So we can do set field for that, which takes the index to the table, which is at -1, -2. So the index to the table we're setting on, which is our, in the past it was our Sprite table, but now it's our anything table. And we want a method called new. So that's all fine. So that's going to get us where we want to be with our new table that's a global, and we're putting on our new method. We need one more thing though, because when this function gets called, or when Lua calls it for us, we also need to know the type information that we're going to create. So we need to push on an up value for that into the function. So up values are covered in one of the previous videos, but you can see why I covered it now, because what we'll do is we'll push on a light user data, because light user data is just a pointer. So we'll push on a pointer to this type, this class to register, which is just an RTTR type. You can see that reference to a type. So we'll just push on the pointer to that as our up value, and we have to cast it to a void star. The one says void star, and then we say there is one up value in that function. So remember, that gets popped when you push the C closure. That gets popped up off the stack. So this all this code here stays the same. It's just setting the field new on that table and on with that closure, and that's gone at the point that this happens down here. So that should get us where we want to be. We'll have our create user datum function, which will have our up value, which is the RTTR type. So in there we'll know exactly what type we need to create. So all we got to do now is we've got to create that function. So here we go. So it's the standard function signature that Lua says we have to have, which is it takes a Lua state and it returns the number of values you are leaving on the stack. So first thing, actually, we could just maybe check that that's being called. Or we can check that it compiles. Let's just see. Is that so? Yeah, I've got a breakpoint there. So that is being called. So looks like the code here is working. It's bound that value, and our call to up here sprite.new is actually invoking that function, but currently we haven't written it yet, so it's not doing anything. So where were we? We are too far. Wait a second. There it is. So first thing we need to do is probably recover our up value. So we want Lua to user data, and it's Lua up value index. And there's only one up value. There's one, and that starts at 1. So that should recover our RTTR type, and that would be a pointer to it. I'm gonna just dereference it so that we don't have to mess about too much. You should probably do better checking on this when it comes to it, but it would be a pointer to an RTTR type, and I'm going to just directly dereference it there, and I'm not even going to check it. So if you're doing production code, you might want that a bit safer with some better error checking or whatever. And then, so we now know the type that we want to create. So every time this gets called, there'll be a different, remember that it's the same function, but a different up value can be called with different types. So that's the key thing about up values. Same function, but different up values when it's called. So what we need to do now is we need new user data. So this is what we did before. This is how we did it before anyway. And we did like size of, and it was Sprite before. But we actually haven't got, we're actually just binding any type now. So we want the type to create. And we can do get size of, can we? So that would give us a user data, or user data like big enough. That just returns a void star. So I'll just call it UD for user data. So that returns us a void star with an amount of memory big enough to hold this type that we're creating. But the problem with that is that then what we'd have to do is create one of these types. So we'd have to go type to create, and then we'd say create, which would give us one of these RTTR variants. So the variant is just like the type. It's like an object that knows its type. So that will have us actually, what would we call that? I'll just call that V for now. So that variant is going to contain whatever the type that was in the sub value, and we've created one there. But as you can see, this doesn't really fit in with our current way of allocating the memory for the new user data, because we've had to create it in this way. So I suppose there's a few ways around this. We could, what are the ways of doing it? We could, is there a way in here that we can like give it a pointer and say placement new on that, but there isn't. So it seems like that the RTTR library here isn't able to actually let us like placement new the variant that's being made into the memory that we have allocated for it. So unfortunately, we're going to have to we're just going to have to do the create like this, and then we're going to have the we're probably going to have to store the variant. Actually, one thing we could do, I'm just thinking, is we could actually make a user datum that is the size of, let's just see if this works, which is the size of an RTTR variant. Like that. So So the user datum now is just an actual variant itself. So what we could do then is we could turn that into an RTTR variant. So a reference to variant equals this. Oops. Actually, I'm just thinking what we've actually got to do is we need to call the constructor on it, I think. Let's try it this way anyway. So there's our user datum, and we'll dereference that. So yeah, that gives us a reference to a variant. Can we create a variant from... we could assign the variant to that one. Will this work? So that might be what we want. So actually our user datum now is actually just the variant itself. So we've just created a variant. But as you can see here, we've not called the constructor on the variant. I don't know if that's gonna be a problem to us because we're assigning to something here that we haven't called the constructor on. So let's see if that actually works. I'll put a breakpoint in the bottom of it. I don't think that's going to work though. Nope, exception violation. So yeah, the operator equals it's move constructing this variant, and is it doing? It looks like it's doing a swap, which is one of the things you do if you're writing a move constructor or a copy constructor or something like that. You can do a swap on it. So we haven't initialized this variant. We've allocated the memory for it there, but we haven't actually initialized it. So I think all we'd need to do is call the constructor on that, and possibly we can actually pass in the type that we created there at this point. So I think that's us good. I don't see anything too wrong with that. So we're getting Lua to allocate a new user data that it's going to manage the memory for. Then we're making sure that, in fact, we don't even need to do this step anymore here, do we? Nope, doesn't look like we need to even do that. So then what we're doing is we're placement newing a variant into that space that Lua's allocated, and we're immediately in the constructor passing in the type that we created. So that'll be like move constructed straight into this variant. So that should be what we want, I think. Let's just see that does that not crash anymore? Nope. So it's not crashed. So it's quite possible that it has successfully constructed that variant for us. I suppose if I'd have left the variant in there that I'd cast, we would be able to actually get an idea of whether it was working correctly. But as it stands, I think that's good. We could just leave that line in for now, just as a comment, just to show us like that's actually what we've got there. So that's kind of like what we did before, except now we're creating this variant. I don't really like the way that we have to like basically like do a memory allocation and then we kind of have to do another one here. I mean, this might not be too bad, but I think it'd be nicer if we could have just allocated enough memory to store the type and the thing that was created all in there, and that type to create would have actually given us a pointer and placement newed it for us. But that's not what we've got, so this should still work, but we're okay with that. And then the only other thing we did in the previous videos is we did a user table, which is just a place where any of the Lua scripter can store any extra information that wasn't available in the native type. So we just do set user value for that. And we want to set it on that user datum, which is now just at the bottom of the stack. So it's at position 1 on the stack. So that should set the user value onto that user datum. And then we're returning, it pops that table off, and then we're returning the user datum. So hopefully, yeah, that should return the user datum. So hopefully that's good enough to get us through the creation of our new type, except now Previously we did that and it was only Sprite, but now we've actually got it so that this can create anything, which is pretty cool, I think. So if we bind another thing, Sprite 2, Sprite 3, Sprite 700, they can all be bound correctly. And nothing's crashed there yet, so we don't really know that that's working properly. Let's get rid of that printf in there. And that's all we need to do. So this is just binding classes to Lua. There we go. So that is us generically creating types from the runtime type information, just doing our new. The next videos we need to replicate all the other stuff that we did. Here we manually bound the methods, which we won't need to do that because we'll be able to bind one method that can call anything, I think. We needed the destructor to be able to be called, and we needed the index and new index methods to be called that could look at all the properties. So we need to go through and replicate what we did here with this sprite, but do it so it'll work on any type. And we'll see if we can get back to the point we were with the sprite, except with just automated registration, that we only have to do this once and then we're all cool to go. So hopefully that's all good. It wasn't too complicated. We're not quite sure if this is working yet, but we've got a pretty good idea that that is actually working. So we'll work on this in the next video and we'll verify that we've actually created our new sprite when we start calling functions on it. So I'll catch you for that one.